Let's look at solving something just a little bit more complicated. Still a logarithm though. So if I ask you to solve log base 2 of x squared plus 2x equals 3. The first thing we need to recognize is that we have x's inside the logarithm, so we've got to break them out. We have to break them out through legitimate means. So how do I do this? How do I rewrite this logarithmic equation?
2 to the third equals x squared plus 3.
So you fly the plane. 2 raised to the third. Remember, let my words echo in your mind. The answer to the log is the power. The answer to the log is the power. So exponents work differently than multiplication. So I'm going to say 2 raised to the third equals the expression on the inside. X squared plus 2x. Right? Please understand that 2 to the third is not 6. I'm not saying anybody in here would say or think that, or that anybody who might be watching this on the internet would think that. If you are thinking that, just hit the rewind button. Try it again. 2 to the third is, everybody? 8. This is not as nice of an equation as the other ones we've seen because you have x squared. Oh no, what are we going to do? What? Factor. Right now?
Well, again, the 8 to the other side.
Yeah, I've got to move everything to one side first, otherwise I get in trouble. So 0 equals x squared plus 2x minus 8. And then if we factor this, how do you factor x squared plus 2x minus 8?
It's going to be 4.
So we need x plus 4 and x minus 2, which means that x equals what?
Negative 4 and 2.
X equals negative 4 or x equals positive 2. Now before you start boxing every answer that you get, when it comes to logarithms, you're going to have to check these guys because logarithms have a naturally restricted domain. So let's come over here to the side and let's check each of these. Let's check x equals negative 4. I just need to plug it in here. And so I'm just going to kind of do this right here. So x squared plus 2x, when I plug in the negative 4, and notice that whenever I plug in, I use parentheses so I can pay attention to my signs. Here, this gives me a positive 16, minus 8, so I get 8. Put it back inside of this logarithm. What is it? Log base 2 of 8.
3.
Log base 2 of 8 does equal 3, so that guy does work out. I know for sure that x equals negative 4 is a solution. Now let's check the other guy. Let's check x equals 2. So again, I'm going to take the x squared plus 2x, plug in the 2. So 2 squared plus 2 times 2, do my arithmetic. 4 plus 4 gives me 8.
Same.
Yeah, it's going to end up being the same thing. So you can check to see that log base 2 of 8 does equal 3. Both of these solutions are valid. And that's it. That's all you have to do. But you do need to check your work on this. Always check your work.
Because if you were to get, like, what, negative 8 or something?
Right, so if for some reason this caused you to get a negative 8, here's what we know though. For logarithmic expressions, whatever answer you have inside of here has to be positive. So this guy can never turn out to be a negative number. If it does, you're just wrong, because you can't do that. It's undefined. But we didn't have that issue with either one of these. Let's take a look at another example, though. That's going to be just a bit different. So if I take log of x plus 4 plus the log of x minus 5. And I say this equals 1. The problem that we're running into here is that we cannot instantly go and fly the plane, as we would like to say. I have to bring these guys together as a single logarithm. When you have addition right here, what does that mean that you can do with the expressions inside the log? Bring them together as a product. Now, that does not mean you multiply the logarithms. That means that you have a single logarithm that inside contains the two factors x plus 4 and x minus 5. Now, what's understood to be the base here when we're talking about the logarithm? It's understood to have a base of 10. And so by writing that there, that's going to help us in our next step when we fly the plane. So now that we have a single logarithm, we fly that plane, so the base 10 raised to the first equals what's inside. Remember, this is your base, raised to that number, which is the power, is going to give you the expression on the inside. So 10 raised to the first equals the product of x plus 4 and x minus 5. So let's go ahead and work this out. On the right side of the equation, when you FOIL, x squared minus 5x plus 4x minus 20. And here's the thing. Once you're at this point, until you get x by itself, you don't even have to worry about the fact that this was a logarithmic equation. You have something that's nice, you have something that's quadratic, and you know how to solve these guys. As we were mentioning before, you want to make sure that everything is on the same side so that hopefully you can factor. So let's go ahead and subtract 10 on both sides. So 0, combine like terms on the right side, x squared minus x minus 30. Does this factor? And you find factors of 30 that subtract 1, 6, and 5. What are your signs, though?
You have a negative 6 and a positive 5.
So x minus 6 times x plus 5. Which means x equals what?
6.
X equals 6 or x equals negative 5. Should I go ahead and box both of these? I mean, I did in the last problem eventually, right?
Check.
I should probably check these. So let's check x equals 6.
Which one do you plug it into? Your final equation, I guess?
Always go back to your original. Whenever you check, you always check against the original equation. So if I plug it in here, that would give me log of 6 plus 4 is 10, plus log of 6 minus 5 is 1. Work this out. What is log of 10?
Log of 10.
Yeah, what is log of 10? This is understood to be base 10, right? So it should be 1. And what's log of 1? What power of 10 gives you 1? 0. And when you combine these guys, you get 1. Is that a true statement? Weren't we trying to get this to equal 1? So that checks out, which means I can box x equals 6 as a solution. Check the other one, though. When I check x equals negative 5, if I plug in negative 5 here, I get negative 5 plus 4, so that's negative 1, plus plug in negative 5 here, so negative 5 minus 5 is negative 10. But what did I just say about the kinds of numbers that can be inside of a logarithm?
Always has to be positive.
It has to be positive, which means this stuff is undefined. So I cannot include x equals negative 5 as a solution. So this is an extraneous solution. We didn't do anything wrong. We did nothing wrong. We combined those logarithms. We rewrote this as an exponential equation, which led to something that's quadratic, and we factored and finished. Here's the thing. If the equation had started right here, right at the very top, if it had started right here, both of these solutions would have worked. Because by starting right here, if I plugged in -5, yes, that would have been a -1. Yes, it would have been a -10. But the order of operations would have dictated that you multiply the insides first before you evaluate the logarithm. So you would have had a -1 times -10, which makes it a +10, which would not be a problem. However, we didn't start there. We started here. We started with two separate logarithms, which meant that we had to evaluate this guy first and then that guy before we could add. However, by evaluating them in that order led you to stuff down here, which meant that we were undefined before we ever had a chance to put those guys together. So you always go back to the original equation so that you understand where you're plugging it into and what those original constraints would be. That's why we only have one solution in this particular problem.